Welcome to the demo of our system Morphus. In this demo, we want to demonstrate that our system Morphus supports read and write operations on a database table while its data is being reconfigured. We run Morphus on a 10-machine cluster. This cluster consists of one machine running MongoS and the workload generator and 3 replica sets. Each replica set contains a primary and 2 secondaries. There are 3 config servers, each co-located on a physical machine with a replica set primary. All physical machines are Dell D710 nodes. Each node has 4 cores, 12 GB RAM, and 750 GB disk space. All machines are connected to 100 Mbps LAN switch. We use the dataset of Amazon reviews as our default collection. The database size is 1 GB. We choose product ID as the old shard key and the user ID as the new shard key. For workload, our injection rate is 100 operations per second, with 40% read, 40% updates, and 20% insert. We compare Morphus with MongoDB reconfiguration solution, where a DBA needs to export the data, change the schema, and re-import the data. The main metrics we compare are reconfiguration completion time on the left and read-write latency during the process of schema change on the right. The blue and red lines are read-write latency, respectively. Note that if the latency drops down to -5, it indicates the query fails. Due to time constraint, we fast-forward the process of reconfiguration correspondingly, and we'll show the completion time in the end. We run an export and re-import script on MongoDB. Export command writes data into disk. Because it grabs database logs, during this time, read-write latency increases and fluctuates a lot. After export finished, we change the schema by deleting the table and create a new one with a new shard key. All read-write operations fail during this time. Then we re-import all data into the new table, but most of the read-write operations still fails at this point of time. Let's see how Morphus achieved the same reconfiguration goal but concurrently support read-write operations. We run a reshard command on Morphus. In order to continue serving operations while the data is being reconfigured, we first perform reconfiguration transfer only among secondary servers. In secondary servers, we create an empty partition with a new shard key, and then we isolate these secondary servers and migrate data among them. In the meantime, the primary servers can still serve all read-write operations. These operations are further replayed in the secondary servers after data migration so that the secondary servers can catch up with primary. At this point of time, data in secondary servers are up to date and partitioned with a new shard key. We swap the role of secondaries with a primary and commit the schema change to config servers. During this time, very few operations may fail due to the write throttle. The number of writes that fail is low. For the uniform workload, fewer than 2% writes fail. We conclude that under reconfiguration, the read and write availability provided by Morphus is high, while latencies of successful writes degrade only mildly compared to where there's no reconfigurations in progress. However, in MongoDB reconfiguration solution, the read-write latency still suffers because, first, some of the data is still missing due to the ongoing import progress, and second, import command locks the database and generates high read-write latency. At last, our system Morphus completes reconfigurations in about 7 minutes, while MongoDB reconfigurations take about 15 minutes. We conclude that Morphus supports faster reconfigurations such as shard key change, while only mildly affecting the availability and latencies for read and write operations. Thank you for watching.